Hello guys, welcome to another video. This is the complete A2 Physics Guide Part 4. So Part 4 is the final part and it only consists of Chapter 14, Medical Physics. This is the largest single chapter in your A2 syllabus. There actually isn't uh, much concept that I can teach you because the concepts are very basic and two-liners. You have a total of four topics for your medical physics, which are PET scan, X-rays, CT scans, and ultrasound. So what I've done is, as I said in the earlier video, that as making the video and writing them take a lot of time and increase the size of the video, I've already written down everything that you guys need, which I am going to be narrating them slowly and explaining things where required. And after explaining each section, I will make sure to write down the concept required for that section. So you can go through this, write it down in your own free time. Basically, to give you guys an overview, uh, I have compiled question papers from 2007 to 2025 and have written every single question that have came in the last um, 30 years for medical physics because as you guys know, this is the only chapter where everything is related to memorization. Okay, so don't worry, it looks a lot, it isn't much, and hopefully we can go through them quite fast. So let's start. X-rays. Now, method of production of X-ray. It's electron hitting metal target. Wave in X-ray is transmitted. Explain how X-rays are produced at the metal target. So electrons are stopped on impact with metal target. Kinetic energy lost by electrons is emitted as X-ray photons. Explain how X-rays are produced for use in medical diagnosis. So you have to write electrons are accelerated by an applied potential difference. They hit metal target and decelerate. Kinetic energy lost by electrons is emitted as X-ray photons. Okay, number five is how is intensity and hardness of X-rays controlled? Intensity is controlled by varying filament current, and hardness is controlled by varying accelerating PD. If you want to increase intensity, increase the filament current. If you want to decrease intensity, then decrease the filament current. If you want to increase hardness, then increase PD. If you want to decrease hardness, then decrease PD. Okay. Why a continuous spectrum of energies of X-ray photon is produced? So the answer is electron decelerates on hitting metal targets, so X-ray photons are produced. There is a range of decelerations slash accelerations. Photon energy depends on magnitude of deceleration. Okay. Number seven is why aluminum filter is placed in the X-ray beam. So aluminum filter absorbs most low energy X-rays. X-ray beam contains wavelengths. X-ray beam contains wavelengths. Low energy X-rays are harmful to the body. Okay, difference between X-ray image of bone compared to muscle. Bone is seen as lighter and muscle is seen as darker. Bone has higher. This is linear absorption linear attenuation coefficient value. So absorbs more X-ray than muscle. Mm, Okay. Explain continuous distribution of wavelengths in X-ray graphs. X-ray photon produced when electron are accelerated, range of accelerations in target, hence distributions of wavelength. Okay. Explain the sharp cutoff at short wavelengths. Electron stopped in single collision gives all of its energy to one photon. 11 is explain series of peaks superimposed on distribution of wavelength. The excitation of electron in target. Number 12 is causes of lack of sharpness of X-ray image. You can say anode area is large, scattering of X-ray beam. Number 13 is what is meant by 80 kilo electron volts of X-ray. X-ray produced when electrons hit metal target. Electrons have 80 kiloelectron volts of kinetic energy. Okay, why long wavelength X-ray poses a greater hazard than short wavelength X-rays? So long wavelength radiation is more likely to be absorbed in the body. That's why they are pose a greater hazard. Okay, so how to minimize dangers caused by X-ray? Again, it's a repeated question. Place aluminum filter in the X-ray beam. Okay, what is hardness of the X-ray? So hardness measures the penetration of the beam. Greater the hardness, greater the penetration. Linear absorption or attenuation coefficient. Parallel beam in it is a parallel beam in matter where I intensity is equal to intensity naught e to the power minus mu x, where I is the transmitted intensity, I naught is the initial intensity, and x is the thickness of the medium. Factors affecting sharpness of X-ray, size of anode, scattering of X-ray beam, pixel size. Explain why X-rays can be used to produce image of internal body structures that have good contrast. So the body has bones and soft tissues. They have different attenuation coefficients. Transmitted intensities of bone and tissue are very different, thus they have good contrast. So what's contrast? Contrast is the difference in degree of blackening, and attenuation is loss of energy. Okay. So, okay, theory, right? Theory. Okay. So for X-rays, right. Give me a moment. Right. Theory, X-rays. So imagine a medium. Let's say this is the skin or a bone. And this section is skin that has thickness X. I naught is the initial intensity. What passes through is the transmitted intensity. Okay. Therefore, we have the formula I is equals to I naught e to the power minus mu x, right? Where, right? Where uh I is equals to transmitted intensity, uh I naught is equals to incident intensity, x is thickness of medium, and mu is linear absorption or attenuation coefficient. I like to say linear attenuation coefficient, but it does not matter what you write in the exam. Now, there is also a graph that you're required to learn to answer a few questions. Actually, sometimes you're never actually given to draw the graph, but the question gives you this graph and tells you and asks you a few questions. Okay, so the graph looks like this. This side you have intensity, and this side you have wavelength or frequency. You might have anything depending on the question. Okay. Let's just usually have wavelength, but remember you can have frequency. Just you can also have frequency. Now, the graph looks so what do we learn? X-rays are produced when electrons hit a metal target, right? So when they hit a metal target, the graph looks like this. And then there's a range of discontinuations. Just increase this, which leads to this. Right. This is the graph that you're supposed to know. I will label the uh, questions that you are going to be asked based on this graph. Yes, one of them is this one, the series of peaks, sharp cutoff, finally continuous distribution of wavelengths. These are the four questions that you're going to be asked based on this graph. Okay, now moving on, we have positron emission tomography, PET scan. Explain how positrons came to be present in the body during PET scanning. Introduction of tracer into the body that contains a positron emitter. That's the answer. How positron causes the emission of gamma radiation from the body during PET scanning. Positron interacts with electron, pair annihilation occurs, mass of particles converted into gamma ray photons. Okay. Next is annihilation, a particle interacting with its antiparticle so that mass is converted into energy. Four is particles converted in annihilation are positron and electron. Number five is how gamma rays are used to produce an image. The gamma photons are detected by detectors. They arrive at different times. The tracer builds up in the location of the gamma ray, thus producing an image. Luckily for you guys, there is no serious math involved there is no serious math involved with positron emission tomography. This is actually linked with your chapter, nuclear physics. So yeah, it doesn't have any special theory otherwise. So let's go to CT scan. Okay, number one, why X-ray images of multiple sections are taken during CT scanning? They are combined to create a 3D image. Sharpness is ease with which edges can be distinguished. Advantage and disadvantage of CT scanning are compared with single X-ray are advantage is produces a three-dimensional image. Disadvantage is much greater exposure to radiation because you're having to take more X-rays. Okay. Purpose of computed tomography is to produce a 3D image of structures. Outline the principles of CT scan. So first, this is step by step. X-rays are used to scan certain sections. This is repeated at different angles. Data is processed to give 2D image of the sections. This is repeated for many sections and combined to build up a 3D image. This 3D image can be rotated and viewed from different angles. Uh, the the math for CT scan is also very easy. Show you guys CT scan. Okay, actually no. Let's try the full thing. Computed tomography. Thing looks better, right? CT scan. Okay, nice. All right. Okay. So in CT scan, you'll be given a diagram like this. Okay, be given a diagram like this, and it will be cut in multiple sections. Okay. You'll also be given, okay, these will be labeled A, B, C, D, where A, B, C, Ds will be numbers. You'll be given that an information that is background radiation is X. Okay, and you will be told to find out the new value. Find new value of sections. Therefore, what you do is a minus x, b minus x, c minus x, d minus x. You will subtract and then you will simplify. Subtract and simplify. Oops, sorry. All right. So let's say your values are, let's say your values are 16, 20, 44, and 50 and 58. Sorry, not 58. So 64. 64. Okay, let's say BG is equals to 4. Therefore, your new, therefore your new values are 12, 16, 40, 60. This is divisible by 4. So if you cancel them by 4, you will see 4, 3, 4, 4, 4, 10, 4, 15. Therefore, new answer is 3, 4, 10, 15. There you go. Okay, which you just insert into this again. All right, simple as that. No complicated stuff. Okay, I think I can just take up more space than I need. Right. So that was computed tomography. Okay, finally, is the biggest one of all. It's bigger than X-rays. So, ultrasound. Describe how reflected ultrasound pulses may be used to obtain diagnostic information about nature of boundary. So you can say time delay gives information about depth, intensity gives information about nature of boundary, specific acoustic impedance of a medium, product of density of the medium and speed in that medium, method of production of ultrasound, vibrating quartz crystal, waves in ultrasound are reflected. So, why is gel applied to skin during ultrasound scanning? Without gel, almost all of the incident ultrasound is reflected from the skin. With gel, almost all of the incident ultrasound is transmitted into the skin. Describe the function of quartz crystal, generates and detects ultrasound. Applied PD causes crystals to vibrate. Describe qualitatively how the specific acoustic impedances uh, between two materials. Okay, there should be, I missed a word. Should be between two materials affect the intensity reflection coefficient at a boundary between the materials. So, after that, if difference between the specific acoustic impedance is similar, then reflection coefficient is zero. If difference is if difference is very different, then reflection coefficient is nearly one. So, guys, okay, yeah, all right. Then number 7 is outline the use. Okay, this is a series of questions that that CIE has asked in the past papers, even from 2022 to 2024 that came. So you should memorize this. Outline the use of ultrasound to obtain diagnostic information about the internal body structures. You have to say ultrasound pulse reflected at boundaries. Gel is used to minimize reflection at skin. It's generated and detected by quartz crystal. Time delay between generation and detection gives information about depth, intensity of reflected waves gives information about boundary. Explain the principles of the generation of ultrasound waves for use in medical diagnosis. Quartz crystal is used, alternating PD applied across crystals, causing it to vibrate. Resonance occurs when frequency of potential difference matches natural frequency of potential difference matches natural frequency of crystal. Natural frequency is in the ultrasound range. Number nine is explain the principles of the detection. So we have detection, generation, and use. So of ultrasound waves are, you have to write pulses of ultrasound produced. It is incident on quartz crystal. The waves make the crystals oscillate. This generates an EMF across the crystals. Okay, number 10 is why there is little transmission of ultrasound waves from air into skin. To say specific acoustic impedances of air and skin are very different. Intensity reflection coefficient depends on difference between acoustic impedances. Most ultrasound is reflected, so little transmission. Why ultrasound emitted in pulses? You have to say that allows reflected signal to be distinguished from the emitted signal. Detection occurs in the time between emitted pulses. So state how the ratio IT by I naught depends on ZA and ZB. If ZA is greater than ZB, then ratio is 0. If ZA is similar to ZB, then the ratio is nearly 1. Now, guys, do you see something confusing? The statement I wrote is opposite. Usually it is if ZA and ZB if ZA is greater than ZB, then ratio is nearly 1. And if ZA is similar to ZB, then ratio is 0. The key factor is IT by I naught. We usually work with this is usually IR by I naught. However, the question told us IT by I naught. The previous statement is valid for this ratio, and this statement is valid for this ratio. Right. So this was something that you have to be careful with. Trust me, they got a lot of students with this question. This one was a very tricky question. Okay. State uses of piezoelectric transducer, microphone, pressure sensors, clock, 14. Finally, why IR by I naught? See, this is IR by I naught is the one that you guys mainly work with. So why IR by I naught is equals to e to the power minus mu x applies only to parallel beam. Intensity changes when beam is not parallel. It decreases when beam is divergent. And finally, why acoustic impedance is important, considering reflection of ultrasound at the boundary between two media. Difference in acoustic impedance determines fraction of incident intensity that is reflected. Okay, so that's that. That is the entire SAQ part of ultrasound that you sadly have to memorize. I had my fair share of trouble when I was doing this, but I'm glad I could escape from it. So the theory part, I'll finish it in one go. Okay, so CT scan. Sorry, not CT scan, ultrasound. What's wrong with me today? Right, ultrasound. Okay. Now, in ultrasound, there's only one thing that we work with, that is specific acoustic impedance. The value of Z. Now, let's say there are two medium. Okay, so there are two medium. We can say this is medium one and this is medium two. Okay, there is incident intensity. Some of the intensity is reflected. So this is I naught, this is IR. Okay, And some of the intensity, sorry, excuse me for my bad drawing, but you'll get the idea. And some of the intensity is transmitted into this bump into the new medium. Now, the formula for specific acoustic impedance is Z is equals to density multiplied by speed of that medium. Okay, now we're unit is kg per meter per second, per meter square per second, where where Z is specific acoustic impedance in kg per meter square per second. This is density. Rho is density in kg per meter cube. Uh, right. And finally, C is speed of the medium. Usually, you can also write V, but in our syllabus, this is given as denoted as C. So nothing to do. I can't teach you guys the wrong thing. I can teach you guys less, but not the wrong stuff. Right. What's next? Okay, this was one, right? And number two that we have to work with is intensity reflection coefficient. So the intensity reflection coefficient is, give me a moment. So it is IR by I is equals to Z1 minus Z2, or actually, let's not say Z1 and Z2. So ZA plus, oh sorry, ZA minus ZB whole square is equals to ZA plus ZB whole square. Okay, where, oh, actually, intensity reflection coefficient, reflection slash transmitted coefficient. So this is the intensity reflection coefficient, and IT by IR is ZA plus ZB whole square divided by ZA minus ZB whole square, where where Z1 and Z2 are the values of specific acoustic impedance of two medium of the two medium actually of the two medium. Right. Need more? Do I have to write? Or is this it? Oh, there is one more thing. Sometimes they tell you to find, it's number three, find transmitted intensity. It's very simple. IT is equals to 1 minus IR by I. That's it. So that's all, guys. This is the complete final part of A2 Physics Revision Guide. With this, I conclude this video series. Thank you guys for sticking with me. Uh, Inshallah, I will also be posting um, Pure Mathematics 3 guide in most probably a week or so. But otherwise, take care. I hope this was helpful. Please leave a comment and give me a like, and also reach out to me if you guys have had any question or any problems that you guys are facing. And finally, I'm glad this could help. So yeah, take care, guys, and I'll see you in the next one, inshallah. Okay, bye.